Hi everyone, we are Group 1. Today we are talking about our final project, Multimodal Video Understanding System. And in the past few months, we spent a lot of time in our final project. And thank you for everyone. Thank you for our professor and our TAs give us this opportunity to research this topic. And okay, let's start.
Okay, now I'll go through the overall design and the implementation of our multimodal video question answering system. So after the video is uploaded, the system first determines whether it should be treated as a short or long video, using 180 seconds as the threshold. For example, a 200 seconds video will be split into two 80-second video and a 40 seconds video, and short video are processed directly as a whole. And for the long videos, we split them into smaller segments and each about 80 seconds. And this segmentation is due to the input constraint of the Llama 2 model, which allows at most 45 image frames as visual input, giving a standard frame rate of 30 frames per second. An 80 seconds clip contains about 2400 frames. So we sample about one frame for every 53 frames to stay within the model's limits. We are preserving as much visual information as possible. For short videos, we implemented a pipeline that performs frame sampling, subtitle generations, and visual encoding. These visual features are then combined with the user's questions and passed directly to the model to generate an answer. For long videos, the system first divides the video into multiple short segments and process each segment using the same pipeline as the short videos. After that, each segment's summary is generated, and together with the subtitles, these summarizes are transformed into vector index and be sent to the semantic library inside the memory storage. When the user submits a question, unlike the short video cases, the question is encoded and converted into query embedded, which is then used in a implemented RAG, which is the retrieval augmented generations, to find the most relevant segments, including the summaries, subtitles, and the construct informations. And this retrieves information and are passed to the model to produce final answers. And then we design to implement an evaluation agent that will identify any module level errors that can help the system to refine the future responses.
Our goal is to build a multimodal that can understand and reason about videos. So we select EVA-CLIP as visual encoder and Llama 2 as large language model. Our training focuses on projection layer and LoRA. So we mainly do our experiments on GCP by using an L4 GPU with only 24 GBs RAM. This resource-constrained environment forces us to apply useful strategies. So most of the parameters in Llama 2 and all of the parameters in EVA-CLIP are kept frozen. We also compress every four consecutive tokens into a single richer token. To achieve this, we divided the training process into three stages. So for the first stage, we perform image text alignment. The dataset we use is Lion, which contains about 400 million image text pairs, but we only use a subset of about 1,000 samples. As you can see here, the dataset consists of many images with text explanation. Our goal is to teach the model to understand the images, and after training, we will pass the checkpoint to the next step. So for the second stage, we conduct video text training. The dataset we use here is condensed movies, and we utilize a subset of 300 video text pairs. As shown here, there are many videos with description. In this stage, we aim to teach the model how to understand the motion in the video. Okay, So for the last stage, we perform video instruction fine-tuning. The dataset we use here is video ChatGPT. As you can see here, it contains many videos paired with human instructions, such as the questions shown here, along with the answers generated by GPT. So we use this data to train model to learn how to follow human instructions and provide useful answers. Okay, so let's have a look at our training loss. Due to limited computing resources, we could only set the batch size to 1 in these 2 stages. However, we can see the overall trend is converging downward. Looking at these 10 steps, the downward convergence proved that our LoRA and projection layer training was effective. So we have uploaded our model to the Hugging Face.
Okay, let's start our product demo and let's watch this video. We input our video in our product. And then the video end, we enter our questions. How many cars are there in this video? Okay. And this our agent begin to generate the answer. Okay, there are 3 cars in this video. Yeah, we get an answer. And by the way, when we start our product and wherever you use our product, you enter the video and enter the question, we will see that in our log, it's convenient for us to do another work or improve our product. However, there are a lot of challenges and difficulties in this period of time. First is our hardware constraints. It's our first time to train the 7B parameters model, and we tried a lot of way in our own GPU or in the Core Lab. Finally, we decided to use the GCP. However, the 7B is still too large for us. And then it's the time limit. At the beginning, we plan to finish all of our algorithm system. However, now we just finished our short video product and then the RAG product. However, yeah, we didn't do the evaluation of the long video, so we don't know how good it's good or not, or what is our next step to improve our product. And we didn't finish our at the beginning. We promised we can enter the YouTube link to get the information or ask the question from the YouTube video. And I almost actually every questions is all based on the limit. If later we have in future we have the opportunity to improve, we will do the further job.